And welcome back to 4th, 5th grade math, and you are with At Home with APS. Hi, my name is Mrs. Gaudette.
Hello, mathematicians. I am Mrs. Sears.
And today we're going to be doing some math, right? Okay, so let's get us started. The first thing that we're going to be doing, we have done this before, but I wanted to think about how to do this. We're doing the Frere model for our academic vocabulary, and I have it already set up for us. What you will need at home is you will need a sheet of paper, and in this paper I will give you directions really fast on how to make that. So you will fold it like a hamburger. Then from there you're just making fourths, so you will fold it again in half like that. And then you'll notice you'll have one end that is not open. Like this one has an open part, this one has a lot of open parts, and this one has one. So the one that really doesn't have anything, you will fold into like a triangle. And then when you unfold it, you will have this. You'll notice lines like right in the middle. You know, I did not mark those lines. You really need to mark the diamond and then the individual quadrants for what we're going to use today. So our word that we're working with is expression. We're not talking about expression, express yourself. No, we're talking mathematical language now. So if we were talking about a mathematical expression, the first this is the first. So we'll go into the quadrant 2. But in quadrant 2, we're going to ask for the definition. All right? What would the definition of a mathematical expression be? Great, thank you. I appreciate your input. So let's go ahead and let's get a definition going based upon some of the stuff you guys yelled out at me. So we have numbers, symbols, and operations. Do you guys remember what an operation is? No, it's not the operation where you're playing that and you go in and it goes buzz every time you hit the side. No, it's not an operation in the game. It's a mathematical operation, right? So we have add, subtract, multiply, and divide. Oop, that got really tiny. I apologize. So we're going to take numbers, symbols, and an operation, group them together, we're going to group them together to show the value of something. Okay. Now, just like last time, I asked you guys for a picture of it, a pictorial representation. So thinking about a mathematical expression, what's a pictorial representation of that? Any ideas? Good. So I'm going to use that area model. So we're going to use one for like 18 times 42. This is my expression. And here's a pictorial representation of it, my area model. And I'm going to put my 18 on the top. So I'll have my 10 and my 8. Yes, in the area model, you've got to separate out into the place value, your 10s, your hundreds, your ones. Then down here, we'll do 40 and 2. So we have 40 up here, and then 2 down here. Do you guys remember how to use this area model? All right, perfect. So hopefully you're doing this with me. We will do 40 times 10, which is, great, 400. And then we have 40, did I say that wrong? 40 times 10 is 400. 40 times 8 is, well, I know 4 times 2 is 32. And then we have our 10s. 2 times 10 is 20. That was easy, right? And then 2 times 8, thank you very much for that. And then with any area model, we go ahead and put those all together. So 400 plus 300, 320, I apologize, plus 20 plus 16. So I'm going to add my 6, my 10s, 10, 20, 30, 40, 50, and then my hundreds, 3, 4, and that gets us to 756. So that's an example of a pictorial expression. Now let's do an example. I'm going to give you an expression. So we have parentheses, 25 plus 9, close the parentheses, minus 4, divide by 2. So this is a little bit more complex expression than the first one, right? Now we're having to think about order of operations. Yep, you guys are like, hey, are you setting me up now? Sure am. I am totally going to set you up now. So think about this. What will we do first? Multiplication, division? I heard that. Add, subtract? Parentheses. We got to do the parentheses first, right? So 25 plus 9 is, my 9 and 5 make 14 plus 20 is 34. And then I bring down the rest of it. So what do I do first? The subtraction or the division? Right? The division. So what's 4 divided by 2? 2. And then we bring down our 34 minus 2. And what does that get us? Oh, my goodness. Thank you for that. I appreciate that answer, for your help. Because remember, it's all of us together, working together to get this done. So this is an example of a mathematical expression. A little bit, so is this. But this one's a little bit more complex. Now, I have here some non-examples. Actually, let me write that down. And I forgot to put my tape on them. So we will be putting the tape on them. So you noticed one of the very first things I said that it was not an expression like, hey, how you doing? I'm happy. Yeah, that's our non-examples, right? That's a great non-example. So I was working last night on this, and I came up with some ones that I think you guys will like. So let me just put the tape on here. All right. So, yes, I'm hiding them from you. Ha, 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 ha. Yep. So the first one I came up with was LOL. There's my expression. Do you guys use that one a lot? Right? I know I do. I laugh out loud all the time. Then I have been using this one a few times lately with everything that's going on, right? We're sad. And here's another non-example. Oh, I love math. It's my favorite thing in the world. Love to do math. And then the opposite, I hate getting sick. So there are some non-examples, and then there are some examples for us. So again, this is a Frere model of our mathematical vocabulary expression. So that leads us into our open middle problem. With our open middle, if you have been with us the last couple weeks, I've done a few of those. Push it over more. Okay. With our, we've done this a few times, but I wanted to just refresh us as anybody has come to us. Who hasn't done this. And what this is you are given some expressions here, and you are told that here's the constraints to the problem. You are to use the digits 0 through 9, only one time each. And then you have to place them in the box so that each expression is simplified to a different odd number. Meaning, so let's think about what that really means. So if I put in here 5 divided by 2 minus 1. So we have 2 minus 1 equals, 2 is 1. 5 divided by 1 is 5. So if I have an answer of 5 here, I can't have an answer of 5 here or 5 here. my answer has to be a different odd number. So let's try this out. I came up with a few because I was thinking I'm going to come over here. All right, yay, there I am. So I'm coming over here, and we just are going to use that to think about the different numbers in. So I know I have to divide. I'm thinking 6 is a bit nice even number. And I wanted to divide it by something that can go into 6, is divisible in there. So think about my divisibility rules. I know 1 can go in there evenly, 2 can go in there, or 3. So I want this answer to be 1, 2, or 3, right? So I know, I forgot because I had thinking here. I did this halfway through and then realized I better figure out where all my digits are and what I have used and what I have not used. 5, 6. Okay, so if I've used 6, I've marked it off because I can't use it again. And then if I do, what could I get here? If I did 4 minus 2, so take away 4 and 2. 4 minus 2 is 2. 6 divided by 2 is 3. All right, so far we got it. But now the rest of my answers can't be 3. That's where our little issue comes up on. So then I have something plus something times something. And it has to be a different odd number. So you know what? I know. If I used a 0 here, I'm going to use 7 because I know 7 is odd. And then, so I got my 0, my 7. What could I do here? Well, 3 would work, right? Oh, would 3 work? All right, we have to do our multiplication first, right? 7 times 0 is, you got it, 0. Plus 3, that does work. Why was I thinking it was going to be 10? Can someone tell me why I thought it was going to be 10? Right, I was doing it wrong. I was thinking 3 plus 7, then times 0. I don't know where I was getting that, but I was doing my order of operations in the wrong order. So that didn't work. Did anybody see my error? Right? 3 and 3. See, this is where it gets tricky. So if that's the case, I can't have 3 here. So what could I use? Where's some odd numbers here? 1, 3, 5. Oh, you're right. Let's use 5. That works, right? We get 5 there. Now my last one is I have a number minus a number divided by a number times another number. Ooh, maybe I should have done this one first. Ooh, can you help me out here? Well, if I put 9 here, that means this whole thing has to equal something less than 9, right? Uh-oh, did I mess myself up and I'm going to have to come back through and change a few things? Probably. You know what? This is a good one I'm going to leave you with. And I'd like you, hopefully you have your math notebook out and you're working on your math as we're doing this with us. Go ahead and write this down and try it yourself. And maybe I made a few mathematical errors and where I placed my digits. Because now that I'm looking at it, I'm thinking, oh, I know something. I could put a 9 here. Right? No, see, look at that. I'm thinking, 9 divided by 3 is 3, but then I'm thinking, well, what would I put here? I don't know. Well, now that I'm trying it, 9 divided, see, you could tell I like math. I couldn't let it go. I still had to sit here and try to figure this out. 9 divided by 3 is 3. 3 times 1, right? That would work, right? 9 divided by 3 is 3. 3 times 1 is 3. And then if I subtract it from 8, 3 I couldn't let it go. Couldn't let it go, right? So you know that I have not met that open middle problem. So I'm going to leave this with you. And I want you to reorganize your numbers so you could try to get where all of them are different odd numbers. And when I did this last night, I just had to move around a few numbers to get that. Well, maybe instead of subtracting 3, I subtract 5. Or something like that. Oh, no, see, that would get me 3 again. See, I can't let it go. But I'm going to have to today. So you guys keep working on that. And we're going to move into our number of the day with Miss Sears.
I really liked how you persevered through that problem. And that's one of our mathematical practices that we need to do, is to make sense of the problems. And I could tell that you were really trying to make sense of that problem, Ms. Gaudette, and persevere to solve them. You couldn't let it go. And that's a great thing to do when you're really thinking about math, because it is about making sense of things in our world and making sense of why we are doing that. And I applaud you for doing that so well. All right, well, we have a number of the day today. Let me go ahead and get this number up here. It is 39. And now pay attention closely. I'm going to say and. Oh, is it over here? 39 and 345 thousandths. Okay? I really emphasize the and, because we know when we have a decimal point in the middle of a number, that always tells us to say and. And I also emphasize the thousandths. You hear that TH at the end? That TH is what's telling us that it's a number smaller than 1. It's like of the thousandths place, okay? So the first thing that we always do when we are working on our number of the day is we want to put it into our place value chart, okay? Now you notice I already have a place value chart written in here. If you can maybe pencil that into your math journal or on a piece of paper that you're working on today, so we can go ahead and work this routine together. All right, so I have some letters represented up here. Those letters are going to tell us which place we're going to be putting our number of the day into. When we see a T, what do we think that T stands for? If you said tens, you're correct. Yeah, that's a tens column, okay? We're going to be putting our tens, the number or the digit that is in the tens place is going to follow in this place on the chart. All right, what do you think about the O? Ones, absolutely correct. So we'll have our tens, our ones. We keep our decimal in check there. Remember, that tells us that this number is smaller than 1. What about this T with a smaller TH? What do we think that stands for? Tenths. Absolutely right. So we would need 10 tenths to make a 1, right? As we're building up on our numbers. What about this HTH? Hundredths. Yeah, it's kind of almost like a mirror image. It goes backwards, you know, when you're thinking about it. And this capital T, capital HTH? Thousandths. You're absolutely right. All right, so let's go ahead and let's get our number of the day, 39 and 345 thousandths, in the right places. Where are our tens? We have 3 tens. Let's put that in there. How many ones do we have? I heard it. 9, correct. All right, what about tenths? How many tenths do we have? 3 tenths. Hundredths? Hundredths, we have 4 hundredths. What about thousandths? 5, correct. 5 thousandths. So our number, we have 3 tens, 9 ones, 3 tenths, 4 hundredths, and 5 thousandths for 39 and 345 thousandths. Wow, it's a pretty big number. At least with using that decimal it is. Now we want to go ahead and if you could go ahead and add some of these terms down here on the bottom of your paper. We're going to be looking at how much more or how much less we can make and represent this number in a different way. All right, so we are looking to see if we can find a number that is 2/10 more than 39 and 345 hundredths, or thousandths, excuse me. So if I'm looking for 2/10 more, would I need to go to my ones? No, I'm not going to need to be looking at my ones or my tens. I'm going to need to be looking at my tenths place. In my tenths place right now, I have a 3. If I was looking for something that was more, I've got to go a number that is higher than that 3. In this case, I need 2/10 more, or 5/10, right? So let's write that number as it should be. We have 39 and 545 thousandths. That's by increasing this number, the 3/10, by 2/10 more to give us 5/10 there. All right. What about 2/10 less? Again, we're going to look back at that 3, but this time we need a number that is smaller than that. We need 2/10 smaller. So as we're working on that number, we could do 39, and 2/10 smaller than 3 would be 145. Let's see. So 39 and 145 thousandths. Did you get that? Of course you did. Good job. All right. The next one, we're looking at 2/100ths more. Again, we're not going to be over here in the hundredths column. We're going to be over in the hundredths column, right? We don't want to be in the wrong place to be able to figure out what that new number is going to make it to be. So are our tens changing? No. Are our ones changing? No. How about those tenths? No. How about those thousandths? No. Our hundredths are going to need to change, and they're going to need to change by that 2 more. Okay, so there's a 4 in there now. What's 2 more than 4? 6. Okay, let's write that number. And 3 is going to stay the same. We're going to make that a 6, and we still have the same old 5. So 39 and 365 thousandths. Good job. What's 2/100ths less? Again, we're going to look back to that 4 because it's on our hundredths column, and we're going to look for a number that is 2 less than 4. 4 minus 2, 2, right? All right, 39. Let's get that 3 going. 39, 3 is going to stay the same. We're going to make that 4 a 2 and then the 5 at the end. So 39 and 325 thousandths is that number, which is 2/100ths less. All right, extra zeros in here. All right, so now we're into the thousandths. We need to find a number that is 2 thousandths more than 39 and 345 thousandths. Well, let's see. Our thousandths column is going to be where our 5 belongs right here. We're not changing anything on our tens, our ones, our tenths, or our hundredths. We're just changing it in our thousandths column. So let's go ahead and add 2 more to that number. Let's see. 39, that's staying the same. 34, let's see. 2 more would be 7, right? So 39 and 347 thousandths is hopefully what you got. And we have 2 thousandths less. So we're going to look at that 5 again. What would that be? 5, 4, 3, 2 less, right? 39 and 343 thousandths. All right. Did you get all that? Wow, that's pretty good. Definitely really good. All right, we always like to also write our number out in expanded form. And if you're familiar with what expanded form is, it is writing that number out to the proper place value that it belongs in. Okay, so when we're looking at that number, 39 and 345 thousandths, we first want to make that 30 in the representation of whatever it is. So that 3 that stands for 3/10 is really 30. And we're going to add in our ones, plus 9. Now we also have to add in our tenths. So what do we do when we have a tenth? Well, we're not going to have any ones, so we always have to put our 0 out there first. We need to make sure we have our decimal. And our tenths is the number, like I said, there's 10 tenths that make a 1. That's directly to the right of that ones place. We would add that number in there. So that was 3/10, right? What about 4/100? You're right, we're going to start with that 0. But this time, do we have any tenths? No tenths there. And make sure we put a 0 there to represent that. And we have 4/100. See if we can figure out the very last one. I already hear you saying you got to start with a 0. We don't have any ones. We don't have any tenths. We don't have any hundredths there. So we need to make 5 thousandths by adding our 5 there, and that makes our number 39 and 345 thousandths. One last thing. We're going to add it on our number line, okay? So one of the things that I wanted to talk about is that there's lots of numbers that could be between two whole numbers. Those are numbers that are, smaller than that 39 and not bigger than the 40, right? So there's lots of little numbers that could be lined in between those two numbers. Numbers are infinite. They could go on and on forever, and even the tiniest of numbers could still be there. So when I was looking at trying to find this number, the first thing I always like to do is just find a midpoint of what that number would be. So if I'm looking at 39 and 40, a midpoint of that number would be 39 and 5/10, right? Because 5/10 is like half of 1, right? So I'm going to go ahead and just make my midpoint really quick with that number. So that is 39. And if I am writing this number, because I want to make sure I'm very clear about having those thousandths in there, I probably want to add those extra zeros in there, just so I know that number is also named as 39 and 500 thousandths, right? Because it is almost half of 1,000. 500 is half of 1,000. All right, so if I was trying to look for some other markers that might help me, maybe the other markers that I'm going to look for are going to be numbers that are halfway between 39 and this 39 and 500 thousandths, right? I think I've said it right. And the 40, right? All right, so halfway between that 39 and 500 thousandths, let's see, that would probably be our 39. I'm going to make a mark right here. And what's half of that 500? Oh, I can already hear you saying it. 250, right? So 39 and 250 thousandths would be a good halfway point, right? Well, I want to go ahead and do the same over here on this side, even though I know my number's probably not going to fall on this side, but I want to know where my next good midpoint might be. So just like this one, if I went 250 and then went 500, what would be the next 250 thousandths that would come up? I heard you. Yeah, you said 39 and 750 thousandths would be a good halfway point between there. Perfect. All right. Now we got to figure out where this number is. I got to break it up even smaller. Maybe I think I'll do by 50s, by 50 hundredths, maybe. That sounds like a good place. How about this number right here? I'm going to say that is the 39 and 300 thousandths. I know I'm very, very close because I really only just need almost quite another 50, but I'm not there yet, or another 500ths, and I'm almost there. Let's say that's going to be my number, 39 345 thousandths. Wow. Did you get that? That's a good place. It's a very interesting number of the day. Wow. Good job on that routine. And remember, you can pick any number that you like. You can use decimals in that number. You could use a mixed number or even maybe a fraction in that number. You can go as big with that number that you like or as small as that number as you like. But we really just want you to be exploring that number and looking at different ways that it could be used. Yep. So have fun. Keep inquiring on those numbers.
All right, everyone. So we're going to move on to our literacy piece of our math today. So we're going to be reading another book. Guys, I always seem to find those math books. So I could hear you go, "Oh man, another math book?" Yeah, but that's what's so exciting is they don't just have literacy books to talk about fiction and nonfiction and different things. They also have them to talk about some math. You can see I'm very excited, always bringing in that math. So we have a book called Anno's Magic Seeds, and this is written and illustrated by Mitsumasa Anno, and I apologize about the mispronunciation. And it was published by Penguin Putnam Books for Young Readers. Let's get started. The wizard handed Jack the 2 golden seeds. "These are magic," he said. "Bake 1 seed in the oven until it is red and then eat it. You will not be hungry again for a whole year. Bury the other seed in the ground now and take care for it well. I promise you it will grow and give you 2 more magic seeds in the fall." Jack did exactly what the wizard told him to do. The next spring, 1 tiny sprout came up. It grew and grew into a sturdy plant. In the summer, 2 beautiful flowers bloomed on the plant. A little later, 2 fruits appeared where the flowers had been. In the fall, the 2 marvelous fruits produced 2 seeds, just like those the wizard had given him. In the winter, Jack baked 1 seed to eat and buried the other in the ground. The next spring came, just as before. 1 tiny plant grew from the seed Jack had buried. Summer came. 2 beautiful flowers bloomed on the plant, followed by 2 marvelous fruits. Fall came, and again, the marvelous fruits produced 2 seeds. In the winter, Jack ate 1 baked seed and buried the other seed in the ground. Once again, in the year after this, 1 plant came up and 2 flowers bloomed, and 2 marvelous fruits grew, and 2 seeds were made. And again, Jack ate 1 seed and buried the other. All right, I got to stop there because I got to ask you, have you recognized a pattern happening here? Right? It always seems to be he's eating 1, he's taking 1, burying it in the ground. What is he doing then? Aha, yes. Then it blooms, 2 flowers, 2 seeds, he eats 1, buries it, so on and so forth. Do we know what kind of pattern that is? Yeah, it's a repeating pattern. So let's read some more. Let's see what else is going to happen with Jack. The next year, the flowers bloomed again, and the marvelous fruits grew, and 2 seeds were made. Just as before, again, Jack baked 1 seed, and it ate it and buried the other seed in the ground. The next year, while Jack rested and watched, a plant came up, flowers bloomed on it. Then 2 fruits appeared, and 2 seeds were made. And as before, Jack ate 1 seed and buried the other in the ground. And on the next year after that, the flowers bloomed, and the marvelous fruits grew, and 2 seeds were produced as well. Again, Jack ate 1 seed and buried the other. Let's think. Jack's about to maybe do something different throughout the next year. Do you have any idea what he's going to try to do now? Right? Why would he just keep doing this and only having the 2 fruit? Let's see if that's true. Let's see if that happens. But finally, Jack began to think about it. This can just go on and on the same way forever. He said to himself, if I just go on and on doing the same thing every year, well, this year I will bury both seeds in the ground. Is that what you thought, you predicted? Right? It did happen. So let us go and see if what's happening now. I will get through the winter somehow by eating something different. So that winter, he buried 2 seeds in the ground. He tended them very carefully. The next year, that is the first year, after he planted both seeds, what do you think happened? In the spring, 2 sprouts came up, and in the fall, 4 seeds were produced. In the winter, Jack baked and ate 1 seed and buried the other 3 seeds in the ground. All right. So, how many seeds do you think he'll get now? He buried 3 seeds in the ground. Right? So if he buried 3, he's going to get 6. Okay, let's keep reading and see what else happens. Then in the spring of the second year after his discovery, 3 sprouts came up, and in the fall, 6 seeds were made. That winter, Jack ate 1 seed and buried the other 5. He made a noisemaker to scare away the crows and sparrows so they wouldn't come and eat the seeds. When the wind blew on it, the noise it made startled the birds. Well, the next year, that is the 3rd year after he got the idea, all the sprouts came up in the spring. And in the fall, 10 seeds were made from the 10 marvelous fruits. In the winter, Jack buried 9 seeds in the ground. He baked 1 seed and ate it. The next year, the 4th year in the spring, there came the sprouts, and in the fall there were 18 seeds. That winter, Jack buried 17 seeds in the ground. The next year, that is the 5th year in the spring, all the sprouts came up, and in the fall, the new seeds were made. That winter, Jack ate 1 seed, and he buried the rest of them in the ground. Okay, so what do you notice now? I can hear you guys. I can hear it. Right? That's exactly what's happening. So he buried 2 seeds. Instead of just 1 seed popping up and having one that's buried every year, now he's burying 2 seeds, getting 4, eating 1 of them, burying the rest, and it doubles, and then he gets another one, eating only 1 and moving on. So it's a pattern. Is it the same as the last one? No, the last one repeated over and over. He always buried 1 seed, got 2 in return. Now, because he buried the 2 seeds, he got 4 seeds. He's only taking 1 of those 4 seeds, so he's burying 3 now, and then he got 6. So I have a question for you. How many seeds do you think we would have if this pattern continued? And what kind of pattern is it? Right, this pattern is continuing to grow. So after the 10th year, how many seeds do you think he will have? To give you a second to think about that. What would your estimate be? I hear some of you saying 50, 60. I heard someone said 100. Heard another person said 1,000,000. Whoa, that was a lot. Well, you know what? We're going to work that out and see how many seeds would we have after 10 years. So let's go ahead and let's get up and let's move over here so I can find my paper. Aha. Sorry about that. I had to find my sheet, and so I'm going to move this really fast so it's not right on top of us. So we have a predicament. We want to know how many seeds after 10 years. So how do you think we might be able to solve that? We could use a graph. We could just plot how many it would go. Someone said, yep, you could use a table, or you could just show your mathematical equations as you go through and do your work, but if you do that, it needs to be organized. Don't forget that. So if I was to approach this, I would like to do it in a table. If we did it in a table, what should we include in that information? All right, maybe the years, right? Because that was a lot of information in Anno's Magic Seeds that I'm like, whoa, if I didn't have the years, it would be really hard. What else should we include in that? How many seeds he got, right? That's true. How many seeds he ate? Okay. How many seeds he planted? Okay. All right, so should we include how many seeds he ate every time? We could, right? We could do that. What would we have every time in on our table? Because I'm going to do a table, I'll be honest. We would have 1, 1, 1, 1, 1, 1, right? Every year he only ate 1. So let's leave that off. I don't think we maybe need that. We could include it. If you want to, please do. So in your math notebook, let's be doing this with me. So let's go ahead. I'm going to include the year. So we have our year. What else should I include? I like the seeds produced. And I like the seed. How many seeds did he plant each year? Okay. So if we started off with year 1, how many seeds did he? Sorry, yes, I do need little notes every so often. How many seeds do we have on year 1? That's where we might want to go back to the book, right? Because when I was doing this last night, I had to go back to the book several times to figure it out. Because we have a couple year 1s, don't we? We have the very first year 1. Do we want to go all the way back to then? No, because that was a different pattern. We have our new pattern that's that growing pattern. When should we start? Should we start when he decides, I'm going to figure out another way to eat for a year, and I'm going to plant both seeds? We could. Do we start in the year where he already planted both seeds? We could. When we talked in here, let's look back. We had year 1, he says, after he had that really good idea. So it said here, the first year after he planted both seeds. What do you think happened? In the spring, 2 sprouts came up. And in the fall, 4 seeds were produced. So that's the year after. So I'm going to do something that you may have seen before or you may not have seen before. And in that one, I'm actually going to do what's called a year 0. Meaning it's kind of like starting before my very first year because it was the year after. So if I start with year 0, how many seeds were produced? 2 seeds were produced, right? And he said, oh, I got to figure this out. I'm going to eat it. So I'm going to eat other things like normal people, right? Not this awesome person who had a wizard give me a magical seed. And then so he planted both seeds. So that is my year 0, which was his year of eureka. Aha! Then we have year 1. How many seeds were produced? The 4 seeds, right? Because every year, if you planted 2, it doubled every time. Then how many seeds did we plant? Jack plant? Right? Jack ate 1. He always eats 1. So he would have planted 3. So if we were to continue this down to year 2, how many seeds were produced from those plants? 6. We double it, right? Jack eats 1 seed, so we have 5. And we would continue this, right? Year 3, year 4, year 5, all the way to year 10. So this is what I would like you to do. We have not finished reading our book. but I don't want to read that until the next time we see each other so we could talk about how we did our math. But I don't want to do all the thinking for you. So I'm asking you guys to go ahead and work this out through year 10 and see if any of your estimates were correct. Your 50, your 60, your 100, your million, I heard, remember? Someone said million. So let's see if that's true, and I'm going to ask you to continue working on that. And then the next time we see each other, we'll come back, we'll check our math, we'll figure it out, and then we'll read the rest of the book to see what happens. So we're going to now start playing a game. I really like this game. This game is called the factor game. And in this game, what you have to do is we're going to be practicing again, our factors that we did last time. Remember last time we read a book about the 2 ways to count to 10? And we talked about all the different factors to 20? 50, I'm 50. Sorry. Look at me. See, we all have to sometimes recall in our memory. This game is a little different. We're going to need a sheet of paper to keep our score.
Well, let's see.
And while she's finding that sheet of paper, let's go over the rules. You notice my game board only has 1 through 30. No skip numbers like the product game. It's just 1 through 30, all those numbers. So the first player will choose a number on the game board and circle it. The second player with a different color, so you might want to try something different that's kind of close to my color.
Let's see. How about pink?
Sounds perfect. She will try to find all the proper factors of that number. So for example, for 12, the factors are 1, 2, 3, 4, and 6, and 12. But for proper, what it is the proper factors of a number are all the factors of that number except for the number itself. So she could circle 1, 2, 3, 4, and 6, but she can't circle 12. All right. We continue that, and then player B circles a new number. So after you circle all the factors, you circle a new number.
Okay.
And then from there, I have to then circle all the factors of that number. But if she's already circled all of the factors, certain factors, I can only circle the ones that are left. So I can't count those in my total, the ones you've circled, only the ones I've circled. So we continue taking turns circling factors. If by chance I circle a number that has no more factors that Ms. Sears can circle, then I lose my turn and I get no points. We continue like that until there are no more factors that we can circle, meaning a number, there are no numbers left that have a we can circle with factors. And the player that wins has the most points. So we add up our factors.
So let me just ask you, so 1, the very first time somebody could use a 1, that's the only time they could ever use it again and get points with it, right?
Mm-hmm. Yep.
Oh, okay.
All right. So you ready?
I think so. Are you going to go first?
I'll go first.
All right.
I'm being mean because I know this game, and I don't know if Miss Sears knows this game.
I'd rather have an example first.
Okay. So the first player, I'll be the first player. I circle a number.
Ooh.
And then I get that number added to my points. Miss Sears then can circle all the factors of that number. So what are the factors for 29?
Well, I think you picked a prime number.
Our academic vocabulary, bringing in prime numbers.
And a prime number, if we recall, only has one other factor. It's the 1, right? And that number. So I could circle this, but all I have is 1 point.
Yes.
That's not fair.
Pick another color that's kind of light.
Let's see. Let me see if I can find a darker color in here. How about, I'm going to go this way. I'm going to go black.
Okay.
Hopefully you can see that one.
So Miss Sears is now going to circle another number where I get to find all the factors of that number. Remember, strategy.
I'm trying to think of let's see, 27 I know has factors. Let's see, 20. Let's try 23. Right?
Okay, you forgot one of the main rules.
Is that we can't use the 1 again?
Since there are no other factors to 23 besides 1 and 23, she loses her turn.
Ah.
Yep. So I'm going to give her a little leeway on that one.
Okay, let me try a different one.
So
How about,
we'll scribble it out.
let me try 27.
So you have to circle a number that has some factors, even if it's only one factor that I can circle. Otherwise, you lose your turn and you don't get the points.
Okay, I'm going to try 27.
Okay. I'm going to be that person who can't do it all in my head, if that's okay. I am going.
But I would add 27 to my total, correct?
Yes, you would add 27.
Okay, 27 plus 1 is 28. So
All right,
I'm
so
closer to her number.
27. Remember how last time I said I like to do my factor pairs? So I do 1 times 27, 2 times, nope, it's an odd. 3 times 7, 4, nope, 5.
Is
nope.
it 3 times 7? 3 times 7?
9.
9.
Thank you. See, I love my friend who does math check with me there. 3 times 9, 4, 5, 6, 7. I don't think there are any other factors. Now you're making me second guess myself if there's any other factors. I can't circle 1. She already has that. So I can circle 3 and I can circle 9.
Okay.
So 9 plus 3 is 12. I add, remember how I told you I have to add that up. So that's 1, 10, 40, 41.
Okay. So now you pick a new number, right?
Yes.
Okay. I think we only have time for maybe one more number each.
Yeah. So I'm going to add 4 to that. So it's 45.
Okay, so you picked a 4. So if I'm thinking I can't use the 1 times 4, what else would it be to make 4? It'd be 2 times 2. And really 2, it's a square number because it's a number multiplied by itself, the 2 times 2, right? So I can only add 2, right? That's all I can get. Let's see, let me put 2 on there. So if I had 1, 28, 29, 30, you're still ahead of me. Let's try, maybe I'll go low this time. Let's try, let's try 10.
Add it to your total.
Okay, so let's see, 40.
So if I did this 1 times 10, all right, I can't pick the 1. 2 times 5, so I have 5. 3, 4, nope, so I just add 5 points to mine. All right, let me pick a new number. Ooh. I'm going to add 18.
Okay. Let's see. So 18. So I know 1 times 18. It's an even number, so it's going to be divisible by 2. So 2 times 9. 9's already circled. So is the 2. 3 can go in 6 times. 6 has not been circled. Let's see. 7, 8. Nope, I think I can only do 6, right?
I did that strategically.
Okay, and I think we only have like a little bit more time.
All right, so we're going to go ahead and stop there. We could continue this game, but as you can see, this is just a way so you can see how it, I can't even talk, see how you would start it up. So we want to thank you again for joining us today at home with APS. Have a great day.
And I think we still have maybe a couple more minutes, or like half a minute. Well, but maybe you can play this game. As you can see, something that might be very easy for you to create at home. We just did a number from 1 through 30 of each of the numbers. That this would be a great game to play with an older sibling or parent or anything. And we had a lot of fun with playing with you today. And we certainly enjoyed you joining us here at Home with APS. Have a good evening. or have a good day.
Bye.
Bye.